Hello, dear students. Today we are meeting with a chapter of your 10th standard, that is metals and non-metals. Let us discuss about this chapter in detail, which is quite more important for your 10th examination. Here you can see an image. In this image, you can see various pieces of various metals. You can see brown color beads here. Those brown color beads, reddish brown color beads, are of copper beads. Similarly, here we have copper wire also, and we have some silver beads here. Silver sheets are also given in this image. This image indicates various or a few metals that are available in the nature. Here we have four images. You can clearly see here we have a bottle, okay, filled with gas, actually that is chlorine gas, and here we have sulfur powder, and this is bromine, which is liquid. Okay, this is bromine, and here we have white color substance, that is phosphorus. So what are these? Sulfur, bromine, phosphorus and chlorine. Yes, these are nothing but non-metals. So in this chapter, we'll discuss in detail about metals and non-metals. This is the third chapter in my textbook. Okay, let's move forward. What are the learning points of this chapter? In this chapter, we are going to learn in detail about physical properties of metals and non-metals. Dear children, what do you mean by physical properties? Physical properties are those properties which are visible to us, which we can see, which we can feel, which we can touch. That's physical properties. We are going to discuss in detail about physical properties in this chapter of both metals and non-metals. Chemical properties of metals and non-metals. Chemical properties are nothing but properties which a metal or a non-metal show when it undergoes reaction with some other substances, maybe with oxygen or water, like this. That's called as chemical properties. Metal reactivity series. In this chapter, we are also going to discuss about what are the reactions, reactivity or reaction capacity of the metals, various metals, how we can compare them, which is more reactive, which is less reactive, will be understood in this chapter. Reaction of metals with non-metals to form ionic compounds will also be discussed. Ionic compounds, its formation and properties. Lastly, we are going to discuss about extraction of metals, which is generally called as metallurgy. Very important concept indeed. Now, what you have learned in the previous class, that is, you have learned in your previous class 9th standard that elements are classified as metals and non-metals. They are broadly classified as metals and non-metals, isn't it? So here we have a periodic table. Can you see, children? In this periodic table, these elements which are in green and yellow are nothing but metals, and these elements which are in blue color are nothing but non-metals. Okay, and there are few in this zigzag path. Okay, that few metals in this zigzag path are nothing but, these metals in the zigzag path are nothing but metalloids, which have both the properties of metals and non-metals. So elements are broadly classified as metals and non-metals, which you have already studied in your 9th standard. Now, let us understand physical properties of metals. What are the physical properties that we are going to discuss? First physical property that we are going to discuss is about metallic luster. This word luster is new to you. Luster means it's shining properties of metal. So metallic luster is most common property shown by most of the metals. They'll have shiny appearance. That shiny appearance is called as luster, lustrous property. So if you take sample of iron, copper, aluminium and magnesium, okay, and if you note the appearance of each sample, you will note that, you will observe that they'll have shiny appearance. But if the metals are being kept for longer time, you need to clean it generally with sandpaper to observe its appearance, because those metals kept for longer time would have reacted with the atmosphere and some layers would have been formed on those metal surfaces, which will generally fade its shining nature. So second point they have given, this is one of the activity from our NCERT textbook. Clean the surface of each sample by rubbing them with sandpaper and note their appearance again. So when you note its appearance, definitely they'll have shiny property. A newly purchased copper wire for various electrical purposes, right? It will be having shiny surface. Gold, definitely gold will have shiny appearance. Silver ornaments that we wear will have shiny appearance. Platinum is also a metal, have shiny appearance. Aluminium foil, which we generally use for wrapping the food items, it will also have shiny appearance, that is lustrous property. You can see a beautiful bangle made out of silver, which is having shiny appearance. You can see a pendant and a chain made from gold that have shiny appearance. Maybe this shiny appearance itself will attract most of us, attract more customers to purchase jewelry. So this is also one of the reason why gold, silver jewels are made. Metals in their pure state have some shining surface. That shining property is called as metallic luster. First property that you need to remember. Now, second property that we are going to discuss is hardness. Metals are generally solids, okay? And generally, I'm telling, not all, exception is always there. So these metals, which are generally solids, will have uh, definitely solids are hard, that you have learned in your 9th standard. So this hardness is general for most of the metals. It's common for most of the metals. Generally, metals are hard. So if you take small pieces of iron, copper, aluminium and magnesium, and if you try to cut these metals with sharp knife, and if you note its observation, you will be able to note that iron, copper, pieces of iron, copper, aluminium or magnesium cannot be cut that easily with knife. Okay, but hold a piece of sodium, okay, with a pair of tongs and try to cut it. Okay, we should always handle sodium with utmost care. The reason we'll discuss in coming slides, but I'll give you a hint because that's most reactive. Okay, yeah. So the sodium, if you take with a pair of tongs and try to cut it with knife, it can be cut. That's because sodium is quite soft metal, though it is solid. Not just sodium, But even lithium and potassium are also metals which can be cut with knife. So we can consider that these three metals are exceptional metals which can be cut with knife. Whereas generally metals are hard. I have been using the term generally metals are hard. Generally metals have lustrous property. Generally because it's common for most of the metals. But there would be or there can be some exceptions. Okay. These lithium, sodium and potassium can be cut with knife and they have low densities also and low melting point also. You can see those three metals here. These three are nothing but sodium, lithium and potassium. This is actually lithium, this is sodium and this is potassium. You can see they are being stored in some liquid. Do you know which liquid is that? Yes, it's nothing but kerosene. Kerosene is used to store these reactive metals like lithium, sodium, and potassium. Next property that we are going to discuss is malleability. What is this term malleability? Malleability means it's a property, is general property of metals. Property of metal where it can be beaten into sheet. If you are given with an iron nail and you are asked to beat it continuously with the help of hammer, when you try to hammer it continuously with putting a lot of force and pressure, you will note that the iron nail will generally flatten. Okay, that's because it's due to the pressure, it's slowly converting into sheet because of property of malleability. Take a piece of iron, zinc, lead, and copper. Place any one metal on a block of iron and strike it 4 to 5 times with hammer. What do you observe? You observe that these metals are flattening. Repeat with other metals. Record the change in shape of these metals. Okay. If you do this particular activity, you will get to know that metals can be easily beaten into sheet. Here you can note in this image, person is using aluminium foil to wrap the foot. Aluminium foil is thin sheet of aluminium that has happened just because of this particular property of malleability. And here you can see gold foil. Gold foils made out of gold is also because of this property of malleability. Generally, metals can be beaten into thin sheets. This property of metal is called as malleability. So, generally, metals are malleable. They can be beaten into sheets. You might have seen copper sheets also, which we use in laboratories. And even you might have seen to the small kids. Okay. In Kannada, ತಾಯ್ತ ಅಂತ ಹೇಳ್ತಾರಲ್ಲ, ಅದನ್ನ ಕೂಡ ಕಾಪರ್ ಅಲ್ಲಿ ಬರೆದ್ಬಿಟ್ಟು ಅದನ್ನ ತಾಯ್ತದೊಳಗಡೆ ಹಾಕಿ ಮಗುಗೆ ಏನು ಆಗದೆ ಇರೋದಕ್ಕೆ ಕಟ್ತಾರೆ. ಸೊ that is also made up of copper sheet, which is because of its malleable nature. Gold and silver are most malleable metal. Gold and silver, because of this, gold and silver are widely used in jewels also. In jewels, whenever they are making necklaces or any other ornaments like anklets and all, it should be converted to sheet also. Earrings and all, it should be converted to sheet also. So malleable property of gold and silver help them to convert them into various shape of ornaments, various shaped ornaments. Now another property is about ductility. Ductility is another property of metals. What do you mean by this ductility? Let us know that ductility is another property similar to malleability. In malleability, metals are converted to sheets. In ductility, metals are converted to wires. You might have seen these wires, widely used wires in electrical appliances, electric materials. It is copper wire. One more image. Yeah, here also we have some wire made up of silvery white metal, probably aluminium. It could be aluminium. So these wires are made because of these properties of ductility. Ductility is nothing but property of metal to be drawn into sheet. The ability of metals to be drawn into thin. Sorry, just uh, I mistake. I have done a mistake, small mistake in the definition of ductility. Ductility is properties of metals to be drawn into wires. The ability of metals to be drawn into thin wires is called ductility. Gold is most ductile metal. Do you know 1 gram of gold can be made into very thin wire of almost 2 kilometer length? So you can imagine 1 gram I'm speaking, not 1 kg. Okay. So you can imagine how much ductile, how much high ductility that the gold is having. Okay, fifth property that we are going to discuss is conductor of heat. Generally, metals are good conductor of heat. Let us understand about that by understanding this activity. Here they have given a simple activity. Look at the image that would help you to understand the activity much better than any other. That is, here they have taken a stand, okay, and there is a clamp, okay. To that clamp, they have put a metal wire, okay. They have put a metal wire, okay, and with the help of wax at the end of the metal wire, they have put a pin, okay. They have attached a pin, and with the help of burner they are heating another end of the metal wire, another end, okay. What would happen gradually? Yes, you have guessed it right. Gradually this wax will melt and pin will fall down. Why does it happen? That's because this metal which is getting heated up in this end will transfer the heat through the rod to the other end. That means metals are transferring the heat. It is conducting the heat. It is passing the heat. Hence, it is good conductor of heat. Take aluminium or copper wire, clamp this wire on stand as shown in this particular figure. Fix a pin to the free end of the wire using wax. Heat the wire with a spirit lamp or candle or burner near the place where it is clamped. What do you observe after some time? Note your observation. Does the metal wire melt? Metal wire generally do not melt at very low temperature. When very high temperature is provided, then it can melt, but not at lower temperature which is supplied with burner or candle. Metals are good conductor of heat and they have high melting point. They do not melt easily at very low melting point. They'll have very high melting point. The best conductor of heat are silver and copper. So you need to remember this. Silver and copper are considered as best conductor of heat. Lead and mercury are comparatively poor conductor of heat. They are less conductor or they do not conduct heat as much as silver and copper do. Gallium and cesium have very low melting point. These two metals will melt if you keep them on your palm. If I'll give you cesium or uh, gallium, and I'll ask you to put on your palm. By your body temperature itself, that's 35 to 32 to 35 degrees Celsius. In that temperature itself, this gallium and its cesium will start to melt. That means they have very low melting point, whereas generally metals have high melting point. So here we are studying about two concepts. One, metals are good conductor of heat. Another one, they have high melting point, except gallium and cesium, which will melt on a palm. Okay. Next property, sixth property, is conductor of electricity. Metals are generally good conductor of electricity. The reason is actually they have free electrons to carry the current. Set up an electric circuit as shown in image, which I'll show. Here you can see they have taken a battery, and with a crocodile clip and a wire, they have attached battery to a bulb, okay, to the terminals of the bulb. Another terminal of the bulb is connected to switch, which is having free ends with the crocodile clips. Okay, in those free ends I can insert any object, maybe a coin or a rubber or a pencil or a piece of copper, piece of iron, or even my gold ornaments can be put in the gap. If the bulb glow, what does it indicate? It indicates that whatever material is put in that gap would conduct electricity. Okay, if the bulb doesn't glow, then material put in this gap would not conduct electricity. Generally, metals are good conductor of electricity. So we have seen many applications of conductor of conduction of metals. They are used in electric wires. You can see in bulb they use a metal called as tungsten. A thin wire which you are able to see here is made up of tungsten, a metal which will conduct electricity. Copper wire and aluminium wires are used for electrical wires to pass or to conduct current. Seventh property is sonority. What is the meaning of this sonority? Sonority means ringing sound produced by metals. When metals are beaten on each other, or when a metal is hit with another metal, it will generally produce that ringing sound. That property of a ringing sound is called as sonority, or metals are said to be sonorous. The metals that produce a sound on striking a hard surface are said to be sonorous. That's the reason metals are used in temple bells, church bells, which produce that ringing sound once hit. Okay, and even metals are used in musical instruments like guitar, violin, and all. So these strings of metal used in violin and guitar will produce that ringing sound, which help the instruments to produce melodious sounds. Another property is states of matter, which I have already discussed in the previous slide, that metals are generally solids, but there are some exceptions. Generally, metals are solids at room temperature, but mercury is exception. Do you remember, children, where do we use mercury? Yes, you have guessed it right. Mercury is used in thermometers. So this mercury is actually liquid at room temperature. Yeah, this is mercury, which is liquid, silvery white in color. It's liquid at room temperature. So these are physical properties of metals. We have discussed 8 physical properties of metals. I'll help you to recall. First one we have discussed about lustrous, metallic lustrous, shining property. Second one we have discussed about hardness. Third one we have discussed about malleability. Fourth one, we have discussed about ductility, wire making property. Fifth one, we had discussed about best conductor or good conductor of heat. Then sixth one, we had discussed about good conductor of electricity. Then seventh one, we have discussed about sonorous, ringing sound produced by metals. And eighth one, we had discussed about states of matter. So these are eight physical properties of physical properties of metals that you need to remember. Now we'll quickly analyze what would be the physical properties of non-metals. Keeping these eight properties, what are the properties shown by metals? Are they a good conductor, or they are good conductor of electricity, good conductor of heat, are they malleable, ductile? We're going to discuss physical properties of non-metals. Non-lustrous. Physical properties of non-metals, they are non-lustrous. That means they do not have shiny property. Except one non-metal, that is iodine. Iodine is purple color having shiny appearance. Purple color salt, it's not salt actually, purple color solid substance which will have shiny appearance. Either solids, non-metals can be either solids or gases, except bromine. Bromine, we have discussed in the first slide, is actually liquid non-metal. Except bromine, all other non-metals are either gases or solid. They are not liquids except bromine. Liquid metal, children, which is a liquid metal that we have discussed? It's mercury. Liquid non-metal is bromine. They are non-malleable. They cannot be beaten into sheets. They are non-ductile. They cannot be made into wires. Have you seen any wire made up of sulfur? No, it won't be there. Wire made up of graphite? No, it won't be there. Wire made up of chlorine? No, never. So they won't be made into wires or they can't be made into wires or sheets. They are bad conductor of heat except graphite. Again, exception is there. Graphite is one of the allotropic form of carbon. So in this graphite allotropic form of carbon, it conducts electricity or else it do not conduct electricity. Non-metals are non-sonorous. They do not produce any ringing sound. So these are the physical properties of non-metals. Okay, so here is a note kept to you at the end. Carbon is a non-metal that can exist in different forms. Each form is called as an allotrope. Diamond is also an allotropic form of carbon, is the hardest natural substance known and has very high melting and boiling point. Graphite is another allotrope of carbon, which is good conductor of electricity. Generally, non-metals are not hard, but diamond is exception. Generally, non-metals are not good conductor, but graphite is exception. Okay. Okay. So that's all for today about physical properties of metals and non-metals. Dear children, will you take few questions? That's important from your examination viewpoint. Okay, let me stop sharing the screen. Okay, take few questions. Take few questions that's important for your examination viewpoint. First one, name a metal that is liquid at room temperature. Second one, name a non-metal which is liquid at room temperature. Third question, which are three metals which can be cut with the help of knife? Fourth one, which are the metals which will melt on our palm? Which will melt on our palm? If we keep on our hand, it will start melting. Which are those two metals? And last question, list down physical properties of metals. That's all for today. Let's catch up tomorrow with another video with a continued discussion of the chapter metals and non-metals. Thank you, dear children.